In the beginning of human space exploration, the spacesuits were custom made. With the beginning of the space shuttle program, there was this idea of abandoning the custom size system and going to small, medium, and large. That worked for a while, but as our astronaut corps is getting more and more diverse, the sizes don't work anymore. The spacesuits that are being used now in the International Space Station by NASA are suits that were really designed in the 70s. These are suits that were originally designed for the space shuttle program. Due to the lack of funding, NASA kept working on them, kept repairing them and maintaining them for all these many years, but really these are suits that are at the end of their useful life.
NASA tried to update its suits in the past. A 2021 report by NASA's Office of Inspector General found that NASA has spent over a decade and an estimated $420 million to develop a next-generation replacement for its aging spacesuits, but failed to produce any operational suits. Estimates show that by the time new spacesuits are actually in use, NASA will have spent more than $1 billion on the redesign and production.
There were two different issues. One was lack of funding. NASA had to get funds, sometimes from other projects to fund their suit. And the second problem was that there was no destination. The projects of NASA have been moving through different political agendas during the last few years, and something that you need in any scientific and technological organization is a purpose and a timeline.
NASA is now going another route, contracting with commercial companies to make and maintain its new suits.
So without further ado, I'm very happy to announce that the awardees will be Axiom Space and Collins Aerospace Industry Team.
This may look like an astronaut training for the Olympics, but that's not what's really happening here.
For the ISS, you want a rigid lower half with the ability to rotate around the waist, and then a consistent working envelope, which is about right here in front of you. Easy to translate along the handrails. So low torque in the upper joints, good dexterity in the gloves is a big one.
Eric Vallis is a senior systems engineer. He's been testing out a prototype of a new spacesuit, which NASA hopes to use on the International Space Station by 2026. NASA's current spacesuits, known as extravehicular mobility units, or EMUs in NASA speak, are very complex.
The current spacesuit has roughly 18,000 components that make it up. And the interior volume of the suit is roughly equivalent to the size of a small refrigerator, about 5.5 cubic feet.
There have been a number of safety concerns over the years due to the aging spacesuits.
We're starting to see some degradation of performance, some components that need to be replaced. So on space station, we're really watching very, very closely the performance of the EMUs while they are still on orbit. In the meantime, these new suits for this particular failure of water in the helmet, the new designs are designed such that that failure mechanism cannot occur.
Inventory issues are also a problem. NASA's Office of Inspector General also noted that of the original 18 primary life support system units, only 11 remain in NASA's inventory to support the ISS program, with only 4 of these units actually on the ISS at any given time for astronauts to use during spacewalks.
These are suits that were originally designed not to be serviced in space, but to be serviced here on Earth, because they were dependent on the space shuttle. So now kind of changed the objective, because they have to keep them up there, and the astronauts are the only ones who can repair and maintain them. So the number is very minimal.
The Portable Life Support System, or PLIS, resembles a bulky backpack and is one of the 2 main components of the spacesuit, or EMU. The PLIS houses a variety of components that perform functions needed to keep an astronaut alive in space, including providing oxygen, maintaining body temperature, and removing carbon dioxide buildup from the spacesuit. The second major component is the Pressure Garment System, or PGS, which is the white garment that surrounds astronauts. Its main purpose is to maintain appropriate pressure around astronauts' bodies to keep them alive in the vacuum of space, as well as protect them from orbital debris. Underneath the PGS, astronauts don a liquid cooling and ventilation garment, through which cool water flows to help regulate their body temperature. The new suit designs follow a similar suit structure, but are modernized.
There's just normal, what we call obsolescence issues. Certain parts we just can't get anymore. And so we are building a new suit so that we can start using new components, take advantage of all of the new technologies that are available to us now that just simply weren't available nearly 50 years ago.
In addition to the fiscal support, NASA also provided the vendors with access to data from the organization's own suit development efforts through its XEMU project.
What we basically did was take that design and we made it available to industry. Because we put a lot of work and taxpayer money into developing that system. And so as industry came in and proposed on the Artemis suits, they were able to use any of the data we had available from the XEMU development effort.
We were actually selected to design and develop and provide those spacesuits for the Apollo mission, along with our partner ILC Dover. We were actually also selected to design and develop the Space Shuttle EMU, or extravehicular mobility unit.
ILC Dover and Collins also designed the spacesuits that astronauts currently use on the ISS. One striking difference, though, is the weight. The current EMU weighs about 275 pounds on Earth, significantly heavier than the prototype that CNBC saw. There are also other upgrades.
This helmet is different than the one that's used on the EMU now. It offers a better range of visibility. It has protective visors to protect from the sun's radiation and glare. The upper torso is adjustable, so it fits crew members better and can be adjusted while they're on orbit or doing a mission to help prevent shoulder injuries and to make their EVA more comfortable for them. The upper arm is also new to this architecture. It provides a better range of motion and a lower torque motion than the current EMU.
Furl says that while the current EMU fits the 5th to 95th percentile of astronauts, this new suit is designed to fit the 1st to 99th percentile of astronauts using fewer parts. As a result, 30% less hardware needs to be launched into space, meaning lower launch costs and decreased crew training time. Another big improvement in this new generation of suits is their increased mobility and range of motion.
Things like standing up, you really got to find the angles to rotate your body, but it's definitely something that we couldn't do before in the EMU.
Extended range of motion becomes particularly important for planetary exploration. Though Collins' contract with NASA calls for making spacesuits for the International Space Station, the company and its partners are designing the suit with future planetary missions, like trips to Mars and the Moon, in mind.
For something like the Moon or Mars, definitely the less restriction you have in the lower body, the better. Being able to catch yourself if you start to fall is a big plus, especially with all the dust concerns. So good mobility, stabilization is important.
One of the biggest technological challenges for going back to the moon is the dust particles, which are like the consistency of talcum powder. They sieve through any fabric. So the fabric has to be coated or solid against the intrusion of dust particles.
A lot of the lessons learned from Apollo need to be applied and incorporated. So greater mobility, reduced mass, greater connectivity for the astronauts. They need a better ability to see what is going on with their suits, communicate with each other, because as we continue to go further and further from Earth, you're going to have all of that capability really self-contained. Crew members need to be able to operate somewhat independently from Earth.
Something else that suit makers have to consider is the length of time that astronauts will be spending on missions.
When we think about some of those longer duration missions, some of the other aspects that we've incorporated is really just the maintainability. The ability to do maintenance at lower levels and enable that work to be done at the destination. So we've incorporated modularity and open architecture, so as new technologies are introduced, they can be incorporated into the suit.
Under the contract stipulations, NASA has asked Axiom to deliver the suits for its Artemis moon mission by August 2025, while Collins' ISS spacesuits are scheduled for delivery by 2026. Prior to being worn by astronauts on missions, the suits have to undergo extensive testing.
We require crew member testing in the pressure garment to make sure they're meeting the mobility requirements. And then we also require testing what we call relevant environments. So that could be a thermal vacuum chamber, that could be in the NBL, that could be actually testing on orbit on space station.
Since NASA is purchasing its suits from Collins and Axiom as a service, the vendors are free to make additional suits for non-NASA customers as well. Though Collins would not disclose the names of any of its other customers, the company says it's speaking with about 8 to 10 companies who are interested in their spacesuit services.
New customers that we're looking at are not just the current batch of commercial space customers. There are countries that are looking to be involved in space that were not in the past able to participate. And as space commercializes and becomes more affordable, those countries now have the opportunity to step in.
Romero also predicts that the design of these new spacesuits will continue to evolve to fit the new use cases of its broader customer base.
Today we use it for maintenance and repair, very little for experiential activities where you're going out and doing space tourism. That's really not a part of EVA today, but that probably will become a part of EVA in the future. Future programs will have more interaction with robotics, so our suit needs to be in a position to be able to communicate with the robotic systems and be able to safely operate around a robot.
And it could be big business. The space tourism market is poised to reach $4 billion by 2030. NASA is also looking beyond commercial companies for ideations of future spacesuits. In 2020, Pablo de Leon and his team at the Spaceflight Laboratory at the University of North Dakota won a $750,000 NASA grant to develop a new 3D printed spacesuit prototype for Mars and beyond. De Leon has worked on a number of NASA spacesuit projects in the past, but says this one's a little different.
Some of the advantages will be first to make replicable manufacturing. The second will be that you can scan the body and then build a suit that will be specifically designed precisely to that particular astronaut. And the third one is that once that our space flights go farther away from the Earth and we go say to Mars, for example, we're more than 1 year away from our planet. And if we need a replacement, say a glove, a boot, any other part of a spacesuit, we're 1 year away to get that replacement. So what about if you can build a machine that will put together your suits and you bring that machine to Mars?
De Leon adds that exploring the surface of the Moon and Mars will likely mean that astronauts will be using the spacesuits much more frequently.
Going back to the Moon will require that we'll do explorations almost every day or every 2 days. The same for Mars.
Spacesuits, I think they kind of hit a nerve with people just because there's a very human element to them. It's exciting to work on something that's so critical, that keeps crew members alive and safe. I know it's a big responsibility that we feel every day when we make decisions in the designs. Yeah, it's really exciting.
Retire the International Space Station without having commercial space stations ready, there's going to be a gap in capabilities.
And NASA's already experienced such a gap. After the agency ended the shuttle program in 2011, NASA was forced to rely on Russian Soyuz rockets to launch its astronauts to the International Space Station. And the US paid Russia a pretty penny, over $90 million per seat. When SpaceX stepped in 2020, that cost was reduced to $55 million per seat.
One of the things that is slowing down this effort that might contribute to a gap in the space station capabilities is the lack of funding that Congress has given NASA to kickstart this commercial space station and commercial low Earth orbit operations.
In fiscal years 2020 and 2021, NASA requested $150 million for low Earth orbit commercial development, but only received $15 million and $17 million respectively. In July, the House granted NASA $45 million for commercial LEO development, less than half of what the organization had requested. Commercial companies can also expect competition from other countries.
However, as we are actively working to continue to do science and research, we understand that the ISS at some point will have its end of life.
But NASA will likely not build the next space station. Instead, the agency will depend on the technology of outside companies. It comes equipped with labs, a gym, sleeping quarters, 2 bathrooms, and the view is literally out of this world.
Liftoff of the Proton rocket and the Zarya control module.
The first segments of the International Space Station were launched in 1998, and since 2000, the ISS has continuously housed a rotating group of astronauts from 19 countries. At about 250 miles above the Earth, the International Space Station occupies an area known as low Earth orbit, or LEO. and houses the only laboratory available for long-duration microgravity research. This research has been instrumental in a number of scientific developments, including creating more efficient water filtration systems and exploring new ways to treat diseases such as Alzheimer's and cancer. But it's starting to show its age.